Welcome to Broadcast Variables and Accumulators. After completing this lesson, you should be able to discuss how to send support data to tasks using broadcast variables and explain how to accumulate information over all tasks for consumption back in the job's driver. First, let's discuss broadcast variables. Imagine a use case where you need a large read-only lookup table for all tasks. You could keep a read-only variable local on each machine rather than ship a copy of it with each task, and it can be any serializable value. Here's an example. We have our states map, which is a map of keys to values, including the abbreviation for a state and the name of the U.S. state. And then we have the state's broadcast value, which is a broadcast representation of that map. If the broadcast variable is mutable, it should not be modified after it is broadcast, because any changes won't be propagated around the cluster. Behind the scenes, Spark is using a peer-to-peer protocol to distribute the value, much like BitTorrent would. Accumulators solve the opposite problem. They accumulate some results over the whole job, even when tasks are distributed around the cluster. Consider, though, that associativity is critical in this case, because you don't have control over how values are accumulated between tasks. By associativity, I mean how you group them. Imagine arithmetic where you are adding values together. If you add 1 plus 2 and then add 3, it doesn't matter if you did 2 plus 3 and then added 1. The grouping is irrelevant. Note, commutativity is not required, because commutativity implies order. Consider this use case. We want to count certain events that occur during job execution, such as the number of bad records we've seen. This is analogous to MapReduce counters. A per-task value is modified through an associative operation where grouping does not matter, and only tasks can modify this value. We have support for numeric accumulators, and we can add new types. Only the driver program can read the result of the accumulator's value. So to create the accumulator, we have our Spark context, and we give it a seed value. We then perform our work, and we add to or increment the value inside our num_bad lines. Spark can rerun failed or slow tasks and run speculative copies. For accumulators used in transformations, such as map or flat map or filter, Spark applies each task's update every time the task is executed. Hence, you could possibly overcount. For accumulators used in actions, Spark applies each task's update to each accumulator only once. If you need reliable counts, only use them inside of actions like for each. Having completed this lesson, you should be able to discuss how to send support data to tasks using broadcast variables and explain how to accumulate information over all tasks for consumption back to the job's driver.